So problem number 3. Design a compression helical spring to carry a load of 500 Newton with a deflection of 25 mm. The spring index may be taken as 8. Assume the following values for the spring material. So some data is given. So permissible shear stress is equal to 350 MPa. Modulus of rigidity is equal to 84 kilonewton per mm square. And wall shear stress factor is equal to 4C minus 1 by 4C minus 4 plus 0.615 divided by C. So here actually we have two formulas for shear stress. Okay. So one formula is used whenever, so that curvature, the effect of curvature is negligible. When the effect of curvature is negligible, okay, then the formula for shear stress is tau maximum shear stress. So tau maximum is equal to Ks into 8WC by pi d square. Okay. So where Ks is equal to shear stress factor. Okay. So Ks is equal to 1 plus 1 by 2C. Okay. It is case 1. Okay. Now case 2. So case 2 where we consider that curvature effect. Okay. So suppose if we consider that curvature effect, then that Ks becomes K. So that K means that K denotes wall shear stress factor. Okay. So that means suppose curvature effect with curvature effect, without curvature effect, with curvature effect. With the curvature effect, maximum shear stress becomes tau maximum is equal to K into 8W capital D by pi d cube. Okay. So where K means walls stress factor, stress factor, shear stress factor or walls factor, simply walls factor. Okay. So without curvature factor. So without curvature factor means shear stress, maximum shear stress is equal to Ks 8WD by pi d cube. So here Ks means instead of walls factor, here we consider shear stress factor. So formula, what is the formula for shear stress factor? 1 plus 1 by 2C. Okay. If that curvature effect is considered, okay, then we go for this walls factor. Okay, then we use this formula. Okay. If that curvature effect is without curvature effect, if the curvature effect is negligible, then we use this formula. Tau maximum is equal to Ks into 8WD by pi d cube. Only difference is this factor Ks and K. Okay. Here clearly given, and the problem clearly given that walls factor. So we have to use this walls factor. K is equal to, so already given in our problem 4C minus 1 by 4C minus 4, 0.61 by 615 divided by C. Okay. Yes. So first note on the given data. So what is the given data? Okay. So what is the given data? So axial load is given. So axial load. What is the value of axial load? Denoted by W. So given data, axial load W is equal to 500 Newton. Okay. Next. So deflection. So deflection is given. So deflection delta, denoted by delta is equal to 25 mm. And spring index is also given. So spring index denoted by capital C is equal to how much? What is the value of spring index? 8. Okay. So here C, it also can be written as, C means mean ratio of mean diameter by wire diameter. So D by D is equal to 8. Okay. So what about other data? So permissible shear stress. So it means maximum shear stress, tau maximum is equal to how much? Shear stress value 350 MPa. 350 MPa or 1 MPa is equal to Newton per mm square. Okay, so MPa ni మనం Newton per mm square కూడా రాసుకోవచ్చు. ఓకేనా? సో నెక్స్ట్ ఇంకేం ఇచ్చాడు డేటా మనకి. సో నెక్స్ట్ modulus of rigidity is also given. G is equal to 84 kilo Newton per mm square. So always maintain all units in one form. Okay, mms. Okay, so mm లోనే మనం ఉంచుకోవాలి. So next, so 84 kilonewton. Let us convert kilonewton into newton. So 84 into 1 kilonewton is equal to 10 cube newton. So 10 cube into 10 mm square. Okay, next, and Wahl's factor. So denoted by K is equal to 4c minus 1 by 4c minus 4 plus 0.615 divided by 6. So substitute C value. C is equal to 8, spring index. Okay, then 4 into how much? 8 minus 1 divided by 4 into 8 minus 4 plus 0.615 divided by 8. Okay, then K is equal to 4 8 32 minus 1 and 32 minus 4. So 31 divided by 28. Okay, plus 0.615 by 8. Now calculate this value. Okay, then its value becomes, so after calculating this value, so the final value, please check 1.184. So value of Wahl's factor K is equal to 1.184. Okay, let's continue. So now we have that Wahl's stress factor. Okay, so K is equal to 1.184. Okay, so next, so here what we need to find. So here we have to design. Okay, here we have to design the compression helical spring. So design means we have to calculate all the parameters like mean coil diameter, wire diameter. Okay, so we have to find all these values. So fine. So we know that the relation for shear stress. Okay, so now maximum shear stress tau maximum. Okay, సో ఇక్కడ మనం ఏం ఫైండ్ అవుట్ చేయాలి? సో డిజైన్ చేయాలి మన స్ప్రింగ్ని. ఓకే, మరి ఏం ఫైండ్ అవుట్ చేయాలి ఇక్కడ మనం? డిజైన్ అంటే ఏం ఫైండ్ అవుట్ చేయాలి? పారామీటర్స్. ఓకే, సో ఏంటి ఒక స్ప్రింగ్ డిజైన్ చేయాలంటే మనకి ఏ పారామీటర్స్ ఉండాలి ఇక్కడ మనకి? సో మీన్ డయామీటర్, వైర్ డయామీటర్, ఓకే, స్టిఫ్నెస్. సో ఈ వాల్యూస్ అన్నీ మనం ఫైండ్ అవుట్ చేయాలి. ఓకేనా? ఫైన్. సో నౌ we have a relation, shear stress. So now we have to use that formulas. Okay, fundamental formula. So tau maximum shear stress. Okay, shear stress in a helical spring. So individual helical spring is equal to, so what is the formula with considering curvature effect? K A W capital D by pi. So again it can be rewritten as K, so 8W d by pi d cube, or d by here d by the small d becomes C, spring index. So 8W, okay, C divided by pi d square. Can you write? Yes, obviously capital D by small d becomes C. Okay, C means spring index. Okay, so K means 1.184. 8 into W means load. So 500 Newton is already given, and the C spring index 8 divided by 5 square. So here the only unknown is diameters, wire diameter. Tau maximum is already given. How much? 350. Okay. Now just rearrange the terms. D square. Okay. Let us take this d square to the left hand side. Okay, and 350 to the right hand side. Then it becomes 1.184 into 8 into 500 into 8 divided by pi into this 350. Okay, Now calculate the value of this term. So if you calculate, you will get the value of this numerator. So this numerator value. So I got 37,888. Okay, 37,888. 8,088. Sorry, 888. Yes, divided by 1099. So this denominator value pi into 350. 1099.6. Okay. So just solve again. Solve this expression. Okay, you will get d square is equal to 34.456. Then the value of d is equal to root over 34 point. So what will happen? 34 point. Okay, root. Then you will get 5.87 mm. 5.87 mm. This is the wire diameter of the spring. Wire diameter of the wire diameter of the helical compression spring. Okay. So similarly, now we have wire diameter d is equal to 5.87 mm. So units are very important. Okay. So మనకు wire diameter వచ్చింది. ఇప్పుడు మనకి ఏం కావాలి నెక్స్ట్? Mean diameter. So mean diameter ఎలా find out చేయొచ్చు మనం? We know that spring index C is equal to capital D by ratio of wire mean diameter by wire diameter. So we have the value of C, spring index 8, D divided by, what are the value of small d? Small d value is 5.87. Okay, then we will get that mean diameter. So mean diameter D is equal to 8 into 5.87. So after calculating, so we get 46.96. So nearly equal to 47 mm. Okay, 47. So this is the value of the mean diameter of the ball. Mean diameter. Okay, mean diameter. Okay, fine. Now next, we need next deflection. You can calculate deflection. So you can calculate deflection. Design, you have to design the spring. So we have to calculate deflection stiffness. Let us take deflection. Delta is equal to. So what is the formula for deflection? So as you know, the formula for deflection. So here he asked to design the compression helical spring. Okay. So design anagane మనం ఏం చేయాలంటే we have to calculate parameters. Okay, all the terminology. What are the various parameters related to that helical spring? Wire diameter, mean coil diameter, deflection, stiffness. Okay. Now we calculate deflection. So just simple formula. Deflection delta is equal to, what is the formula? 8 W CQ N divided by G. Okay, this is the formula. So simply substitute all the values. 8 into 500, load 500, 8 cube into. So here you can see, here N means number of coils. So N divided by, what is the value of G? 84 into 10 cube into small d means 5.87. So wire diameter. Here the unknown, only unknown is N. Okay, number of coils. We have already the deflection. Deflection is already given in the question. So question lo deflection ichchadu. So sorry, mana deflection find out cheyalsina avasaram ledhu. Deflection already ichchadu question. So ikkada mana find out cheyalsindi enti? We have wire diameter and mean diameter. So number of turns find out cheyali. Okay, so spring turns, any turns undali. Okay, number of turns, coils. So any. Okay, so we find out cheyali active coils. Okay, active turns. Okay, so active coils or active turns. So find out cheyalante, so ee expression ichcharu. So delta already ichchadu manaki. Enta ichchadu? What is the deflection? 25 mm ichchadu. So 25 mm. So delta is equal to 25 mm according to the question. So 25. So 25 25 is equal to this, now this expression. Okay, is it okay? Fine. So now it becomes 8 into 500 into 8 cube into n divided by 84 into 10 cube but modulus of rigidity into 5.87. Now here n, now n becomes, n is equal to, right here, so we need n, just take it into 5.87. So now these terms will be in denominators, right? 8 into 500 into 80 cube. Okay. So now calculate the values. So you will get this numerator after calculating this numerator. Okay. So you will get so value like 1 2 3 2 7 0 0. Okay. And denominator becomes 2048 0 0. Okay. Then after solving this, okay, this term, you will get number of springs is equal to 6, approximately 6. Hence the number of springs, number of turns or number of coils, active coils, n is equal to 6. So spring total coils in 6 coils like 6 turns. Okay, 6. Okay, we can say 6 coils. So number of coils n is equal to 6. Okay, you can calculate stiffness also. This is the procedure to design a compression spring.